Hi, this is Cake, and at the morning, and since we are in the playground, let's take a roller coaster and let's take a ride. And actually, I can take advantage of this camera because it's not automatically adjusted. And well, let's get into the action. There is a hill over there. I just try to have some fun. Well, probably the hill is not a good idea. I take a standard view. Now, to start up the morning with some refreshment, that would be, I would go over like a child, right? It's just a toy. We try to understand the toy of the little kids, the magnet. Well, this is what we call upside down. Now, I roll you back right up, and this is what we call lay down. Right? And now, as a kid, this is what we call roll over and turn around. Whoops. Now, let's play along. Don't try to fight it. We will just lay you down a little, so it will make you dizzy. Now, don't fight it to try to, oh no, you are not going back right up. You will still stay lay down, and however, I will give you a moment that you would right up and right back up. And actually, we can take a roller coaster in this case and try to do the spinning and rolling at the same time. Now I'm really taking, well, I'm not doing it too well, but I try to make this point across, and this is so powerful. Well, since we have the fun of rolling all over in 90 degrees and 180 degrees, that is so powerful, and we can take advantage of this with this right angle and perpendicular to make the motor roll so powerfully. And well, just like a kid, just a piece of magnet, what could it do? What is within the magnet? And now we arrived at the usual spot with, I have a set of magnets laying all right down right here, all different kind of shapes. Oops. Now we have handful of them right there. Most interestingly, we have our gas. This time, our gas is this little guy here. I try to catch it in the bright sunlight, or maybe not. Well, now this gas of us is just so important that I would try to record the action of this hourglass. And well, right, here we go. With this camera catching it. Now this gas of us is just so powerful that now it's done. This capture a moment of time. This capture a moment of time in a container of sand. And this amount of sand would represent and capture one moment of time as far as this hourglass can tell. And to go over how on earth the magnets can do such a breathtaking stunt by spinning the motor, I would start with this standard magnet here, and well, I don't have enough yet. Well, I'll use this one. So, well, I use this one. This is our standard magnet with north and south. If we make it a little bit oh wow, well, I try to catch myself back. I cannot do without this guy here. If we make this magnet of its shapes, put it into an L-shaped magnet, that will be standing like something like this. Its original north and original south now is being twisted in a right angle. And we will see how this magnet will try to fight for its survival, and what reactions the whole magnetical field would act. And now let's go over the prologue. This is the magnetical north. The physical north of this magnet is north. However, the energy representation of this magnet is south. No, the physical magnet is north. The energy representation is south. This fight will go on and on and on until this magnet gives up its physical north. And this magnet then will be neutralized. And when this magnet give up its north, it will become south, and this magnet will then be neutralized. Whoa, that's a bad idea to have a piece of paper rolling all over the place. And this will be taking much longer than usual. Whoa. Well, talk about gravity. Let's talk about that wind dynamic. And I'm not building a wind impulsion engine. Please stop. And well, I will stop it all at once. I put it into a little perch there. Now let's get back to the business and neutralize magnet. And there's one more thing about magnets. And if this magnet is traveling in a straight line, okay, it's traveling right, it stopped at point A. However, the energy representation of these magnets do not immediately stop. The energy representation of this magnet will keep traveling and likely to reach up to point B, and then it disappears. It's like when water evaporates. When water evaporates, well, I cannot get the words right. You know what I mean. This is morning. I'm getting